The first of the two technologies that we've been covering in this module are firewalls, which have been around for a very long time. So what exactly is a firewall? Well, it helps us enforce our security policy by creating a wall around the network or area that we're protecting. I'm just kidding, there's no physical wall, but the firewall is an inline defense that can stop traffic from entering or exiting the network based on many variables that are configurable. So, with firewalls from Cisco, we have a few different types that we talked about before. We have the iOS zone-based firewall, the ASA firewall, as well as a Firepower threat defense appliance. The iOS zone-based firewall is just that, a zone-based firewall running on a compatible iOS device. This uses the concept of security zones to protect the network. It's a stateful firewall that can inspect traffic using the nbar functionality. What we do while setting this up would be to assign interfaces to zones and then define how zone-to-zone traffic is allowed or denied. This is meant to complement or even replace having ACLs all over the place on a device. When designing a zone-based firewall solution, you really have to think about what zones you want to define and how you want their access rights to be like. Do you want the WAN, LAN, and DMZ in separate zones? Most likely. But the bigger question is, are there any other zones to define? And do we want the WAN zone to be able to reach the LAN zone directly? Zone-based firewalls, just like any firewalls, should be designed and deployed in high availability mode or HA mode, if that functionality is required. High availability can be configured in either active-active or active standby mode. We're going to mention these modules a lot throughout this module, so let's define them real quick. In active-active mode, two firewalls or other devices have the ability to pass traffic at the same time. Their configurations are typically replicated, and both can provide services, sometimes in a load-balanced way. In an active standby configuration, only one firewall is passing traffic and considered active, while the configurations are replicated over the standby interface. Upon failure of the active device, the standby one would take over and begin passing traffic. Aside from the zone-based firewall, the other well-known firewall type that's available from Cisco is the Adaptive Security Appliance, or ASA. This device has been around for many years, and it is a very solid firewall solution. It introduces several deployment methods that we'll discuss in order to provide solutions that are robust and that can meet your organization's needs. It supports active-active and active standby configurations, but there are some caveats to these setups. So we need to talk about multi-context mode before we can get into any more about the ASA. So let's jump into that topic real quick. ASAs can be configured either in single mode or what's called multi-context mode. Multi-context mode allows us to partition an ASA into more than one virtual ASA. Each of these virtual ASAs are called security contexts, hence the name multi-context mode. What's cool about this feature is that it allows us to mimic several different standalone ASAs virtually, reducing the amount of hardware that we need to purchase. But one important thing to note, and this is in regards to high availability, is that even though ASAs can do both active-active and active standby deployments, if you're running single mode, you're not able to utilize active-active mode. This HA type is only available if you are using multiple contexts. When deploying ASA devices, another deployment option that you have is what is known as clustering. In an ASA cluster, you can group more than one ASA together to appear as one logical device. You might be wondering, what use is this to me? Well, a cluster allows you to more easily manage the devices since you would manage them like a single device. It also gives you much more throughput and better redundancy since all of the ASAs are essentially working together via some sort of load balancing mechanism. This is typically done on the routers surrounding the ASA, both upstream and downstream, so the workload is shared. And what's true with the ASA and FTD devices is that they have the capability to run in two different modes, transparent and routed. In a routed setup for the firewall, it acts as a routing hop. This means that it would be the default gateway for devices behind it. It also means that it's a layer 3 hop, which would be visible in the path for the packets. In transparent mode, however, the firewall acts just like a layer 2 device. Its presence is known only as a bump in the wire and is transparent to the packet path. There are benefits and sacrifices to using each mode, so it would highly depend on your particular use cases on whether or not you would choose one or the other. When deploying your ASA, there's one more thing that you should highly consider. This is whether or not it's going to be terminating VPN connections. VPN termination is a very large use case for enterprise environments, and the ASA does a very good job in that area. If you do in fact want this ASA to terminate these connections, then additional considerations need to be taken with regards to where you place them in your network. The VPN tunnels need to have valid routes to the ASA, and so you may need to place them closer to the border, or have ASAs dedicated to this functionality. You can check out my course, Cisco Core Security, describing and configuring VPNs, for more information about Cisco's VPN solutions. Another thing that I wanted to mention is that while the ASA has been in use for so many years, another device is becoming very popular as a firewall solution. That is Cisco's Firepower Threat Defense, which can be deployed for firewall capabilities just like an ASA. However, the Firepower adds additional next-generation features, which we will cover in the next clip.